Hello everybody, I'm getting ready to do 8.4 for Algebra 1 Math, which is solving polynomial equations in factored form, Part 1, Part 2, Part 3, available here, along as everything else, online tutoring, you name it. 8.4, solve polynomial equations in factored form, Part 1. Here's your standard here. And we have a skill sheet here, 34 points. And we have a notebook guide of 2 points here. Teachers, here's your bell work for today's lesson. Another wonderful word problem here. Give your students explain how you found the answer. So what percent of gene combinations? So we got to find a percentage problem here. Okay, give your students 5 minutes. Okay, welcome back for a bell work answer here. And here is our diagram here. We set up a factor box here, factor boxes here, NA. And then these are AAs here, so this is NA, and then AA, etc., through here. But this is using the factor diagram of factoring trinomials. 50% in the Punnett square, half of the possible combinations are AA, which result in an albino python. So how about that? We get into some here. Solve polynomial equations in factored form. You solve linear equations. You will solve polynomial equations now. So you have vertical motion. So you have learned the property of 0 for any real number A times 0 is 0. This is equivalent to saying for real numbers A and B, if A equals 0 and B equals 0, then AB equals 0. So the converse of this statement is also true and is called the zero product property here. Zero product property. Okay, zero product property, here it is. This is in your notebook. Students, put this in your notebook. Let A and B be real numbers. AB equals 0, then A equals 0, or B equals 0. So you know that much. The zero product property is used to solve, and this is classwork, page 4, is used to solve an equation when one side is 0 and the other side is a product of polynomial factors. The solutions of such an equation are called the roots, and this is where you have x-intercepts. That is usually what your roots are, is where your curve crosses the x-axis. That's usually your root. Okay, example 1. Use a zero product property here. We have this two binomials here, and they equal 0. So x minus 4, x plus 2 equals 0. So x minus 4 equals 0, x plus 2. So we solve either one of these for 0 to find our solution here. X equals 4 or x equals negative 2. And then those are your solutions. Substitute each solution into the original to check it. So you do your multiply out here, forming a trinomial, then you put these in there to see, or you graph it. There'll be another way of finding it. This checks, yeah, and then yeah, and then this checks here as well. So you use this to check it, and what they do is they just combine these together. That's another way of doing it. Okay, so now we're going to do our own here. This is our guided practice. Students, this is you. Pay attention so you can do your independent practice. So our guided practice, solve the equation here, x minus 5, x minus 1. So x minus 5 equals 0, x minus 1 equals 0. X equals 5 or x equals 1. Solution 1. And then here's our check, and they check out. You plug those in. 0 times 4 is 0. It's like negative 4 times 0 is 0. Okay, factoring. To solve a polynomial equation using zero product property, you may need to factor the polynomial or write it as a product of other polynomials. Look for the GCF of the polynomials terms. This is a monomial with an integer coefficient that divides evenly into each. So find the greatest common monomial factor. Factor out the greatest common monomial factor out of that one there. 12x was 42. GCF of 12 and 42 would be 6. the variables x and y have no common factor, so the greatest common factor would just be 6. And this would be your factored form here. Okay, now this one here, what would be our GCF of that polynomial? GCF of 4 and 24 is 4. The GCF of x to the 4th and x cubed would be x cubed. So the greatest common monomial factor of the term would be 4x cubed. We factor that out here, then we have x plus 6 over here. Okay, I've got a practice here. Students, this is you. Pay attention to this. Okay, factor out the greatest common monomial out of 14n plus 35n. So we can factor out 7, can we not? And then we have 2n plus 5n there. That seems to be prime there. And that's part 1 of 8.4. And part 2, part 3 is available here. If you need that, get those out to you. Thank you very much.